Simultaneous equations 4. Okay, let's look at this equation here. Now 3x plus 4y equals 11 and 2x plus 3y equals 8. Now the problem that we have with this question is that there doesn't seem to be any nice number that we can multiply to make it so that we have either the same number of y's or the same number of x's. If we wanted the x's to be the same, we could, for example, multiply the second equation by 1.5, so we had 3 here, both in 3's. But either way we do it, it's going to be kind of horrible fractions, which we obviously would rather avoid using fractions. So in the previous questions we were doing, simultaneous equations 3, we had to multiply one of the equations by a number to make it the same. But here we're going to have to multiply both equations by different numbers in order to get the same number of y's or the same number of x's. Now I'm going to make the number of y's the same. Now the question is, what can I do to make them the same? Well, you've got to think about what you can multiply 4 by and what you can multiply by 3 by to get the same number. Now in this case, can you see that if I was to times the top one by 3, I would make 12 y's. Now if I want 12 y's on the bottom, I will have to times this one by 4. Okay, so I'm going to times the whole of the first equation by 3. I'm not changing any of the answers because I'm multiplying everything by 3. And on the bottom I'm multiplying everything by 4, and I will have 12 y's in both cases. So let's try that. So everything by 3, so 3 times 3, that's 9x, 4 times 3, 12y, and 3 times 11, 33. So this equation, remember, is exactly the same as this one, has the same answers, it's just everything's been multiplied by 3. And I'm going to multiply by 4 on the bottom, so 2x times 4, 3y times 4, and 8 times 4, 32. Okay, now you can see I'm okay because I've got two equations with 12y here and 12y here. Signs are the same, so I'm going to subtract 9x minus 8x, 12y minus 12y, 33 minus 32. So that's telling me that x is 1. Go back to one of the equations. Let's use the second one maybe this time. So if x is 1, this is 2, isn't it? 2 times 1. And then of course take the 2 to the side. 8 minus 2 is 6. So that's telling me that y is equal to 2. So the solution is x equals 1 and y equals 2. We can check that if we want to. 3 times 1 is 3. 4 times 2 is 8. 3 plus 8 is 11. 2 times 1 is 2. Plus 3 times 2 is 6. 2 plus 6 is 8. So it does actually work. Okay, let's do this one. So it's the same idea. The question is, what can we multiply by? Now you can do the x's if you want. If you want to make the x's the same, that's fine. Okay, but I'm going to make the y's the same. So think about what number you can multiply by. Obviously it's going to be a different number for each question. For each equation, sorry. What will you multiply by? Well, I would probably multiply this one by 3 to make 15, and this one by 5 to make 15. So let's do that then. So the top equation, this will be, think about it, what you'll get. And on the second equation, if you times by everything by 5, yeah, whoops, sorry. So obviously this one is 15y equals 5. Okay, so what are we going to do? Add or subtract these? Right, we're going to add, aren't we? Yeah. We have a minus 15 and a plus 15. If you add them together, they're going to cancel out. So 9x plus 10x, that's going to be 0. 33 plus 5. So you can see that x is going to be 38 divided by 19, which is actually 2. And then go back to one of these equations. Let's use this one. X is 2, so 2 times 2, that's 4. Yeah, 1, take away the 4 that you bring over. And then minus 3 divided by 3 is minus 1. So solution is x equals 2 and y equals minus 1. So these ones are kind of the hardest type of questions where you have to multiply both equations to make sure you have this thing where they have the same number of y's or the same number of x's, so that when you add or subtract, one of them will disappear.